In this video we're going to have a look at building data. In the Netherlands we collect and disseminate a large amount of data on buildings. This is done through what has been defined as a fundamentally important data collection, what we call a basisregistratie, translatable to key register. In the Netherlands we have a system of interconnected registrations. There's 13 of them on different subjects, and the building registration is one of them. If we zoom out a bit, we can see that it is part of a larger system still. In Europe, the Inspire directive gives direction to what data we want to collect and share in order to have a coherent environmental policy based on common data. Zooming back in to the actual data in the BAG, we see that there is a number of object types defined. Most interesting for us at the moment is the object type pand, as this includes the ground surface of the building, which we can use in our GIS. However, the buildings are represented by ground surfaces, just flat contours of buildings, and no height information is included. So let's take a quick look at the BAG data. I've downloaded a sample set here, and it includes the pand contours. So if we have a look at this, for example here, we can identify this building, and we see that this is the architecture faculty building, of course. We can see, for example, it has a year of construction 1945. It is a building that is currently in use, and the document on which this is based, the latest document, is from 2002. But there is no height information here. Now you can play around with this, of course. For example, because we know the year of construction, we could use that as a visualization to see where the older and the newer buildings are in a certain area, but that is about it. And we should have a look at the 3D information as well. So the question remains how we can add height to a building. It would be easy to extrude the building if we would just have a simple height value. Well, actually we do. The 3D Geoinformation Research Group of the Delft University has been working at software to combine height information from the AHN, the height model of the Netherlands, with the building contours from the BAG. They have different models for different purposes. In this example, we're going to use the download options for buildings with Z values. There's not just one Z value, as on each roof there are a number of measurements taken. We're going to settle for the height value of the 95th percentile these measurements, which gives a result that can be used for various purposes. Here you see the sample data set that we share with you. I will give a quick rundown of how you make something like this. I start with two things. First of all, I need a contour for the area that I'm looking for. I've just edited this one in a temporary layer. Second is that we need to have a connection to the data set itself. So what I did is that I made a connection with the 3D BAG surface of the TU Delft, which is located, as you can see here. If you make a connection, you can see there is just one data set available, and that is the 3D BAG data set. So we add this to our project, and it will start loading the building information for everything that is in view. That is a bit too much perhaps, so we'll zoom in a bit. So here you can see this is the 3D data. It's just the data set of the buildings. And as you can see, it performs pretty well as long as you have not too many objects. So let's have a look at one of the buildings. By identifying one, you can see the different attributes that this object has. And here you see the roof 0.95 at 18.5 meters high. So this is the height information that we're looking for. Now you can extract this data set, because working from a surface it might not be the best option. So you can best download this one. You can download it by using the extract by location tool. If you start typing extract in the processing toolbox, you will find the extract by location here. I've got it in my recently used here, and what I could do is that I'd say I would like to extract features from the 3D bug that intersect my contour, and I'll save them to a geo package. I did that already, and that the outcome of that is this data set here. So let's have a look. These are the 3D buildings. Let's have a look what we can do with that. One of the things we could do with this data set now is that we change the visualization. Let's have a look at this. For example, we can make a graduated visualization based on the roof value here at the 95th percentile. Let's change the color ramp to a different color, for example greens, and let's classify. Now we can see there are higher and relatively lower buildings. Now this is, if you look at the data closely, you can see there is values of -2 as well. Now the Netherlands is pretty low lying, but -2 for a roof value, that sounds a bit strange. And you can see it here, all the new buildings in this area have this value. Let's check one out. For example, this one has all kinds of roof values that are at -1.5 meters. So what went wrong here? Well, the explanation is pretty simple. The bug data might be very up to date, but the height data is not. So the height data is over 5 years old. If you combine these two, and these are new houses, well, you're just looking at the ground floor basically, instead of the roof. Knowing that, we could make a different visualization as well. For example, here you see higher buildings and lower buildings, but we could also make a, let's say, a fake 3D visualization out of this, using 2.5D parameters. Now here you can see, and let's zoom in a bit to the TU area itself. Here you can see that I've already set up a value here, which is multiplied by 2. That exaggerates the building heights a bit, but also it includes this value as well. So we're looking at the data now, and it is visualized with a 2.5D renderer that gives us an impression of how the height of the different buildings looks. Now this is of course a very simple extrusion of data, but we could do that better as well. We can export this to Rhino. So let's have a look at that. So we're back at our original data set, the 3D Panden. One thing we have to do is we have to make that attribute, the 95 percentile height, into a Z coordinate. We can start by looking here at things that start with Z, and here you see something called set Z value. We have, this is our input layer, we add the Z value to it, but we don't add a value as such, but we're going to have a look at one of the fields. In this case, the 95 percentile. So there we go. We'll first make it into a temporary layer to have a look at how this works. So here we have that, the Z added Panden, and let's have a look if this one will work out. So if I identify a building here, you probably will not see any difference because it is a coordinate and coordinates are not added to the attribute table. However, if we export this one by exporting and saving features as, we could export this as a DXF file, say where we put this one. So here we have the name for that. Coordinate system is the Dutch coordinate system, but what we do here is that, as you can see, if you choose automatic, the Z dimension is already included. Otherwise we'll leave things as they are and we just export them. And when this is ready, let's have a look. It's a DXF, so he doesn't know where it is. It's probably in Dutch coordinate system. So here now we have the DXF dataset loaded into QGIS again. But this is the same dataset that you could add to Rhino as well.